discussed linear equations in both standard and slope-intercept form, we can talk about how to use that information to determine whether lines are parallel, perpendicular, or neither. If you recall from the previous two videos that I did, when they're in a standard form, you have to use a formula to actually calculate it, right? So if I have negative 2x plus 3y equals negative 9, then my slope for this one is going to be negative a over b. So in other words, if my a value is negative 2, I would take negative 2 over the b value, which gives me 2 over 3. So if we're looking at both the blue and the black lines, we can determine whether they're parallel or perpendicular by just looking at the slopes. And we can see that the slope of our black line here is 2/3. You recall that the slope is the number in front of that x value when we're in a slope-intercept equation. Now, since the slope is 2/3, that means that that line will be parallel to every other line that has a slope of 2/3, unless they happen to be the same line, unless the lines overlap. But that's one of those cases that's like a trick question. So if our slope is 2/3 for the black line and our slope is 2/3 for the blue line, that means that the black and the blue are parallel. Because parallel lines have the same slope. But how do we know if the lines are perpendicular or not? Well, it turns out, and we can see as an example here, that when lines have what are called the opposite reciprocal slope, that they're going to be perpendicular. And let me give you an example of what that means. All right, I'm going to use purple here to indicate. So let's start at this point here. On the red line, we can see that if we go down and over, we have a slope of negative 3 over 2. So our slope here is negative 3/2. Now, you see that this kind of looks like it intersects at a 90-degree angle. It's not perfect, but that's as much because the scale of this isn't as perfect, right? The distance up and down between the numbers is not exactly the same on my screen as the distance across. So it's going to be kind of skewed a little bit, at least in appearance. Another reason we don't trust the drawings that we see in geometry. But again, if the slopes are negative reciprocals of each other. So let's take a look. This one is negative 3/2, and our black line is positive 2 over 3. So the signs are different, so we can check that off. And the fractions are flipped upside down. That means that they're going to be perpendicular. And I'll draw this down here. Perpendicular slopes are perpendicular. I'm awesome at this. Our negative, I wish I knew how to edit this out of here. Our negative reciprocals. What in the world is going on here? Oh, that's why. I need this up here. Our negative reciprocals. Okay, so let's compare these two slopes. I have a slope of 2/3 for the black line, and I have a slope of negative 3/2 for the red line. So they are perpendicular if they are negative inverses of each other. This one is positive, this one is negative, so that checks off. And if they are reciprocals of each other. In other words, if the fractions are flipped upside down. and we can see that the denominators and the numerators switch spots in between them. That means that we're dealing with a reciprocal, and so since the lines are opposite in sign and the fractions are flipped upside down between each other, then they're going to be perpendicular. If, for example, I had a fourth line here, and I'll kind of try to draw this as best I can, that let's say has a negative 1/3 slope. All right, make this green. A line with a negative 1/3 slope would not work, okay? Because negative 1/3 and 3/2 are not flipped, and negative 1/3 and 2/3 are not flipped, right? So they wouldn't be. Any other type of line other than parallel and perpendicular, we would just say they're neither.